Solving double linear inequalities. A compound inequality is a statement containing two or more distinct inequalities joined by either the word and or. And means both inequalities must be true. For this example too, we're going to solve the following compound inequalities using interval notation to describe the solution set. In part A, we have negative 36 strictly less than expression negative 4x minus 8 less than or equal to the number 4. To solve for x, that means we're gonna work on applying appropriate properties in algebra to have only x or x with the coefficient 1 in the middle, starting with adding 8 in all three parts of the inequality. So this way, negative 8, positive 8 cancel. The middle part becomes negative 4x. And the left number, negative 36 plus 8, becomes negative 28. The right number, 4 plus 8, becomes positive 12. And then we're gonna divide all three parts by negative 4 to make the coefficient of x to be 1. So this time we multiply or divide by negative number. We're gonna switch the inequality symbol. Okay, so we're gonna swap them from strictly less than to strictly greater than, from less than or equal to be greater than or equal to. And now the expressions that we have, the left hand side becomes the number positive 7. The middle one is just x. The right number is negative 3, which makes sense because 7 greater than x less greater than or equal to negative 3. Or we can write in the way that in common as the lowest number on the left, the highest number on the right, and then the inequality symbol follow that and make these two the same or equivalent statement. Now we have the compound inequality as a solution for part A. Then when we write in the interval notation, it might be convenient to look at the graph and then transfer from the graph to the interval notation. Negative 3 on the left of the value 7 include negative 3, not include 7. So in the interval notation, we have solid or the square bracket on the left side with the negative 3, and then open parentheses on the right with the 7 as the interval notation form to represent the solution set of this inequality problem. The next example, we have negative 4 less than or equal to 2 times the quantity y minus 4, strictly less than 6. We're going to solve for y because y is the unknown or the variable for this problem. First of all, we have 2 multiplied by y minus 4. Going to get rid of the 2 by dividing all three parts with the number 2. 2 is positive, so then we do not switch the inequality symbol. It stays as it is. Then the expression becomes y minus 4 in the middle, less than or equal to symbol, and the left number is negative 2. The right number is 3. And the next part, we're going to add 4 in all three parts of the inequality or the compound inequality. So 4 and negative 4 gone. So we have y in the middle, and then less than or equal to symbol. And the left hand side becomes positive 2. The right hand side becomes positive 7. So at this part, we are done, or we got the solution of this compound inequality problem. Locate the number 2, locate number 7, including 2, not including 7. So the interval notation would be square bracket at 2 and open parenthesis at 7. In this example, we have the compound inequality as the left-hand side expression 2 times the quantity 2x minus 1 less than or equal to the expression 4x plus 2 less than or equal to 4 times x plus 1. So this one, we are going to distribute the coefficient, or basically we expand the expression on the left and on the right of the compound inequality to make it in a simpler form. Then we get 4x minus 2 for the expression on the left part of the compound inequality. The middle part has no change. The right part of the compound inequality becomes 4x plus 4. And next, we are going to work on collecting the x term, or making the middle part to have just the x term. Looks like we have 4x everywhere. And number 2, you can do one thing at a time by similar way that we did in the earlier example. If we subtract 2 or minus 2 to all 3 parts, we get rid of one thing at a time. What we have for the middle part as 4x, and the left side is 4x minus 4. The right part is 4x plus 2. And then we're going to collect 4x all together. So that means we're going to subtract 4x, 4x to all 3 parts. It happens to be like negative 4 on the left, 0 on in the middle, and then 2 on the right. If you look at this step, negative 4 less than or equal to 0, which is true. 0 less than or equal to 2, that is true. So it's true for all. In this case, we can say that the statement is always true for all values of x. So this case, we just write the solution as the set of all real numbers, or in the interval notation as negative infinity, positive infinity.